Hi everyone. In this video we're going to be looking at working with data. Specifically we're going to be looking at the different file formats that P5 supports. We'll look at some of the functions P5 provides to access data, and we'll look at some of the ways that we can use JavaScript and P5 to count and summarize data. Historically, the data that we were using was stored on the computer that we were on. But today it's very common for data to be stored remotely on the cloud, on the internet, or on a remote server on a local network. Within P5 we have a number of different mechanisms for accessing and working with files, and which method you use depends on the file type and where it's located. Some common file formats that P5 will work with include raw text files. These don't have a specific format. They are unstructured data, and any files that are read in as raw text either have to be parsed with no structure or with a predetermined structure where you know the source of the data in the file. CSV files are comma separated values. They're used primarily to represent tabular spreadsheet data. And then we have two structured file types here. JSON, which is short for JavaScript Object Notation, which is a structured format directly compatible with JavaScript, and XML, which is another structured format similar to HTML, but it's just not quite as popular as JSON, although both are definitely still used. So if we are working with raw text files, we'll need to use the P5 load strings function. This will return an array where each element in the array is a single line from the file as one string. Note, if you have multiple things on each line, you will need to process that string in the array in order to break it down into further pieces. We might look at some examples of that later. Load strings should be called from within the preload function to make sure that the file is fully loaded before we access the resulting array. So let's quickly consider a very simple text file. So I'm going to make a new file in here and call it data.txt, and we will just, this will be some sample data. So we have a simple text file there with 6 lines of it where each line is one word. Inside our sketch.js we're going to write our preload function, and inside that preload function we're going to need to read in the text file using load strings. And we can see here, using the autocomplete tool, it tells us the different parameters that we need. I don't have a callback function. We'll talk about those much later, and nor will I have an error callback function, so I can just leave it like this. So normally we would write something like data equals load strings. The problem with doing it like this is that this variable that we've created inside the preload function won't be accessible down here in these other functions because of scope. So we have to make sure that we create the variable at the top of our code. So now we have our data loaded into a variable called data, and if we wanted to, we could write something like for let I equals 0, I is less than lines dot length, I plus plus. I missed a semicolon there. We could write a for loop, and we could print out, or in fact let's do a console.log for each line. And so this will take the result of each line and put it in the console. So if we now click on this example file and press F12 to have a look at the console over here. Oh, what did I write? Not lines, data. And you can see here we have successfully loaded that file in and printed out each element. And here in the lecture slides is just a visual representation of that array where every element contains one line from the text file. Now we could come up with a slightly more complicated example where our text file had some additional words on it, on some of the lines. And we would then need to write code to process each line and do something with it. So the simplest example would be to split each line into its various words, and we can do that using the split function. So what we'll do here is we'll write line equals, or let me change that to words equals data I dot split, and then we'll use a space as a separating character. We can then have another for loop and then print out all of the words that we split. So what we'll do is, just so you can see it all working, we will log the whole line the way we were. Then we're going to take each line, split it, go through that new array that was created by splitting the line, and print out each word individually. So let's have a look at what that looks like in the console. So here you can see the original whole line. This line has multiple words in it, and then you can see that we have processed each individual word. Now obviously in a real application you would need to come up with something to do with that data. And you can see here where there was just one word, we get one word on the original line, and then when we split that, we still just get one word. Another type of file that you might see around is a CSV file. CSV, like we said earlier, is short for comma separated values. P5 has a special way of dealing with PSV files. It will treat them as a table, and you can use a function called load table to bring in the values. So there is an example here that is listed on the Australian Government's Open Data Portal. There's a threatened species list, and there's a link to a CSV file of threatened species provided in the lecture notes that you can click on. The file looks something like this. And you can see here the comma separated values. We have the first row which has the headings, and then every other row has comma separated values. This is what it looks like if we load that CSV file into a spreadsheet. The load table function takes two optional parameters. The first parameter, so this is after the file name, the first parameter is whether or not it's CSV or TSV, which is either comma separated values or tab separated values. And then the second optional argument is whether or not there is a header row to be skipped. So our file is CSV and has a header row, so we would load it with that code there. When we call load table and provide it with a CSV file, it returns a P5 table object. You should click on the P5 table object in the lecture slide to get the reference page for a P5 table, which we will now have a look at. And here we can see the P5 reference page for a table object. We can see the different fields that it contains and the methods that are available to us. In the lecture slides, we run through an example using get row count and get column count to get some stats about the table object. We can use the get function and provide it a row number and column number to get a specific element out of the table. And we could also use, it does say here, instead of using the numerical index, we can also, if our data has a header row, we can use the header name to grab a specific element from a specific position. And here's an example of how you would get all of the different values from a certain header name. And another example where we go through the data and keep track of every time we find a species that has the keyword extinct under their threatened status. So this is an example of counting some statistics about some data. And we can narrow our search to only consider data that is extinct and from Queensland. Some example code down there on how we could filter data using our if statements. Finally, in terms of processing the data, let's consider the use case where we want to count the number of extinct species in each state. So we're trying to get a count for each state. There's a few ways we could do this. In the example code, what we're going to do is create two arrays. The first array will be a list of all the states, and the second array will be a count for each of those states, and we'll start the count at 0. We then simply check that if this animal is found in a certain state and the threatened status is extinct, then increase the count for that state S by 1. We can then go through our states array and print out our frequency histogram.